Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from PEC 1101D1 Group 2. We are given the task for group assignment for Calculus 1. So without further ado, let me introduce myself. My name is Nur Fatinizati binti Salwadi, 2020-464866. My team members, Siti Nur Syakirah binti Syabani, 2020-619842. My second team members is Siti Nurin Najwa binti Muhammad Fazali, 2020-603442.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nurin Najwa and I will continue and start with the introduction of the topic. For introduction to the topic, what is differentiation? Differentiation is the action of computing a derivative. The derivative of a function y equals fx of a variable x is a measure of the rate at which the values y of the function changes with respect to the change in the variable x. It is called the derivative of y with respect to x. Why we use the differentiation? Basically, we use differentiation to determine if a function is increasing or decreasing. A function is increasing if its derivative is always positive and vice versa. Differentiation enables pupils to assess the learning or demonstrate that the learning is matched to the needs, interests, and ability of the different pupils. Differentiation also helps pupils understand and apply both content and process in the learning. Example of application of differentiation in real life: to calculate the profit and loss in business using graph, to check temperature variation, and lastly, to determine the speed or distance covered such as miles per hour, kilometer per hour, and etc. For problem statement, given a function fx equals to x cubed minus x squared. For the A, find the x-intercepts of B. Find the intervals when f is increasing or decreasing. Hence, determine the relative extreme of f if any. C. Find the intervals where f is concave up or concave down. Hence, determine the inflection point of f if any. And the last one is D. Sketch the graph of f using the above information.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Syakirah binti Syabani. I will start with question A. Find the x-intercept of f. Fx equals to x cubed minus 6x squared. First of all, we need to find x-intercept using y equals to 0. So x cubed minus 6x squared equals to 0. Here we can expand or factor the function. So we get the answer. The value of x is x equals to 0 and x equals to 6. For graph through, we have 2 points, 0, 0 and 0, 6. Next step, question B. Find the interval when f is increasing or decreasing. Hence, determine the relative extremum of f. Fx equals to x cubed minus 6x squared. Using first derivative test, we need to differentiate the function. Therefore, f prime x equals to 3x squared minus 12x. Here, we have two choices whether use factor or product rule, but depends on your equation. At critical point f prime x equals to 0, 3x squared minus 12x equals to 0. The value of x is x equals to 0 and x equals to 4 is the critical number for the function f. Next step, for critical point, using the critical number, x equals to 0, then substitute the value of x into the function fx equals to x cubed minus 6x squared. Do the same step for x equals to 4. The critical points are 0, 0 and 4, negative 32 as shown in the slide. Then we proceed to sign analysis. From analysis table, the conclusion of the function is increase, decrease, and increase. From the critical point occurs, we have maximum and minimum point. The function of f are increased intervals, negative infinity 0 and 4 positive infinity. For decreased interval 0, 4. The extremum point, relative maximum is 0, 0 and relative minimum for negative 32.
Hi, my name is Fatin. So I will continue with the question C. For inflection point, f double prime x equals to 0. So we substitute 0 into the function f double prime x equals to 6x minus 12. So the answer is 2. When x is 2, so we substitute 2 into the function fx equals to x cubed minus 6x squared. So the answer is x equals to minus 16. By using concavity test, we can conclude it. Concave down is minus infinity 2 and concave up is 2 plus infinity. Question D asks to sketch the graph. So this is the graph. For the first critical point is 0, 0 and the second critical point is 4, negative 32. For the inflection point is 2, negative 16.
So, for the conclusion is not only we use mathematics formula in this subject, but we can apply in our daily life too. For me, I think application of differentiation is really important to use, because if we do not master the calculation and the subject, then it will be difficult to us for using it in the future.
For this group assignment, I know that differentiation is not just a subject, but it is also can be used for daily life work. In case we need to calculate something related to the differentiations. To be honest, I really enjoy learn this topic.
Conclusion is this topic application of differentiation make me clearly understand the idea of differentiation from first principles, and I can find the critical point, also known as stationary point, from the function given, and determine the nature of some stationary point using either the first or second derivative test. Also, I know how to plot the graph with some information from the sign analysis table. So yeah, this subject so interesting, and now I know how to apply calculus in everyday life.
These are references that we refer to finish this assignment and to solve the questions.